So I want to spend just a minute talking about gamete numbers, so the different variations that you can have in gametes depending on how many traits you're looking at and whether they're homozygous or heterozygous. So there's this formula. I wouldn't memorize this. It's really not a super important thing, but it's kind of cool. So 2 to the n being the number of heterozygous alleles or genes that you have. So take a look at this. Big R, big Y, little y. So you can say, you can have big R, big Y if you FOIL it, right? First, outer, big R, little y, and little r, big Y, and little r, little y. So the important thing here is that each of your gametes has an allele for each gene. So they each know how to make shape and color. And so in this case, you've got 4 different gametes that you can make from that this organism could make, 4 different types of gametes, looking just at these 2 traits. So if you go 2 to the n, that's 2 to the, let's see, number of heterozygotes. So there's 2 heterozygous things. So 2 to the 2 would be 2 times 2, which would equal 4, which works out here. Let's look at the next one. Heterozygous 1, 2, that's not heterozygous, so don't count that because every single one of them would be that. And then you have this. So you can have big A, big B, big C, big D, big A, big B, big C, little d. All right, let's see if I can come up with all these. Big A, little b, big C, big D, big A, little b, big C, little d. Let's see. And then you can have little a with all of these combinations, right? I'm just doing the same ones as above, but this time with little a. So I don't know, let's look at the numbers. 2 to the n would be 2 to the 1, 2, 3, because you don't count that one because every single one just has a big C. That's not adding anything different. So 2 to the 3, which would be 2 times 2 times 2, which would be 2 times 2 is 4, 4, 8. So look, that's how many I came up with. So I looks like I got them all. Hip, hip. How about this one? Yeah. 1, whoops. 1, 2, 3. And I'm not going to count that because that doesn't add any variety there. I'll have a P, big P. This is 4, 5, 6. So that's 2 to the 6. Oh my goodness, I have to do math. 1, 2, 3, 4, 5, 6. Is that right? 1, 2, 5, 6. 2 times 2 is 4. Times 2 is 8. 8, 16. Oh man. 16 times 2, let's see. 6, 32, is that right? And 32 times 4 times 2. Let's see, 4, I think 64. Yikes. Did I do that right? 64 gametes, yay. All right, so these are all the different possibilities that you can make for each of those examples. I wouldn't memorize that formula. I just want you to get the idea of how to do a dihybrid one at least. How many different kinds of gametes could the following individuals produce? Let's see, just 2, because look, little a, big B, and little a, big B. Rather than the formula, this is really what I want you to be able to do. How about this? That's no extra variety, and that's no extra variety. So this is the only thing with extra variety. Every one of them will have a big C, half of them will have a big D, and they'll all have a little e. So there's only 2 types of gametes here, too. So that's the kind of thing I would want you to be able to do. This one has these 2 different things. So big A, big B, big C, big D, big A, big B, little c, big D. Let's see, big A, little b, big C, D, and let's see, little b, little c, and D. I think there's 4 there, which makes sense because 2 to the 2 would be 4. And 1, 2, 3, 4, 5. Oh my goodness, that's 2 to the 5. I'm not going to write all those out. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 8, 16, 32. Should be 32 of those. And this one, oh, that looks awful, but oh my gosh, this is the only thing that's Heterozygous, there's only two different gametes there. They're all going to have a big U, a big V, a big Y, a big X. Is there another one? Oh, sorry, V. So they're all going to look like this. U, V, W, X, Y. Some of them will be big Z, and some of them will be little z. So only two types of gametes there. So n is the number of heterozygous ones, and I'm giving you the numbers for all these, which we already did. Cool, huh? So this looks like it should have a bunch of variety, but there's really only one gene that has two alleles, two different alleles. So list all of the different gamete types that can be produced by an individual whose genotype is this. So let's see. Oh man, this is ugly. A, B, C, D. A, B, C, little d. Let's see. A, B, little c, big D. A, B, little c, little d. Oops, pretend that's a B. A, B, I'm just going along with all these. So that's a big C, little d. That's a little c, big D. And a little c, little d. Now I have to do that whole thing with little a's. Oh my gosh. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 16, right? Because you're going to have little a, big B, big C, big D. Little a, big B, big C, little d. Little a, blah, 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 blah. That was awful. So how about this one? M, N, O, P. This and this are the ones that are different. So that's 2 to the 2. So that would actually be just 4 different types, right? Because you can have big M, big N, little o, big P, little m, and o, p. Or you can have big M, N, O, little p, little m, N, O, little p. So just 4 types. How many different gamete types would be produced by this one? Well, there's only one heterozygous individual there, so you'd only get 2 different types. That's the only difference here. And that is the end of my story.